Hey guys, welcome to your first lesson of our trigonometry unit, which is one of my favorite lessons, or one of my favorite units rather. This one's nothing special, but one of my favorite units of the Algebra 2 curriculum, so I'm a little bummed that it's happening while we are all long distance, but hopefully we'll get back to school together pretty soon and we'll get to at least do the end of it in person. So we're going to start out by just talking about angles. And so your do now is, what do these three images have in common? So what we've got here is a ruler, a thermometer, and I don't know if you city New Yorkers will recognize this last one over here, but that is a speedometer. It measures your speed when you're in a car. But what all of these extra have in common is that they measure those things in more than one unit. So what we have here is a ruler which measures length, and this ruler can measure it in inches or in centimeters. And then we have the thermometer, which is responsible for measuring temperature, and it can measure it in Celsius or Fahrenheit. And then the speedometer can measure your speed in miles per hour or in kilometers per hour. So something that we're really used to from a young age is that we can measure the same thing in different units. And if I tell you that something is 12 inches long, none of you guys are going to go, "What, Miss Bendon, 12? It's 1 foot long." You're not going to be confused by that. You understand that there are 12 inches in 1 foot. But you haven't had to learn a new unit in a while, and we're going to learn a new way to measure angles today. So we measure time in hours, minutes, seconds. We measure distance in inches and centimeters. We know lots of ways to measure, but generally when we've measured angles, we have measured them in degrees. And you guys, I think, are probably pretty used to the idea that 90 degrees is like a corner angle, 180 degrees is flat, and 360 degrees gets you the full way around a circle. But another way to measure angles is in radians. And again, we're going to still be measuring those distances around angles, but now we're going to be measuring them in a slightly different unit. So let's look at what a radian is. A radian is the angle made when we take the radius of a circle, that radius r, look at this diagram over here to the right, and we wrap it along the edge of the circle. And the angle made when we take that length, that is 1 radian. So if we measure them around a circle, there are pi radians taking up half of a circle. So that's what we would call 180 degrees, that flat half circle. That is pi radians. 180 degrees is the same as pi radians. And 360 degrees equals 2 pi radians, the same way that 12 inches equals a foot. This is just the same angle measured in 2 different units. So let's talk about how we go from degrees to radians. And the way that we're going to do this is we are going to do a unit conversion. We just said that pi radians is equal to 180 degrees. So what we can do is to convert 90 degrees into radians, we're going to multiply it by pi radians over 180 degrees, and that's going to be 90 degrees times pi radians over 180 degrees. And just like we can cancel out numbers as they divide each other, degree divided by degree cancels out and leaves us with radians as our unit. Whoops, I wrote an equal sign. I meant a multiplication sign. I'm assuming that if we were having class in person, you guys would correct me on that kind of mistake. So now I've got 90 times pi over 180, and I can simplify that because when I'm multiplying fractions, it's just top times top, bottom times bottom. So 90 is really 90 over 1. I've got 90 pi over 180, and 90 and 180 simplify because 90 goes into both of them. 90 goes into 90 once and into 180 twice. So I end up with pi over 2. So 90 degrees equals pi over 2 radians, or sometimes you'd see it written as 1/2 pi radians. Let's try that again. 270 degrees that I want to convert to radians is going to be times pi radians over 180 degrees. And maybe it's a little less easy to spot what goes into 270 over 180 and 180. So one trick you can do is leave the pi off for a second and just put 270 divided by 180 into your calculator. You'll get 1.5, and you can hit math, enter, enter to get the fraction that is 3/2. And then we'll just put that pi back on, 3 pi over 2. Generally, you're going to leave it in terms of pi. You could put that 3 pi over 2 into your calculator, or even put that 270 pi over 180 into your calculator. Where do we find the pi button? I'm trying to remember. It's second caret thingy will get you the pi, so it's like your exponent button. So 3 pi divided by 2 is something like 4.7123. So we could say that we have 4.7123 radians, but that is really less accurate because we've had to round pi off. We would rather leave it in terms of pi if we can than have a less accurate measurement. And then to go from radians to degrees, we're going to do the same thing backwards. So if we want to convert pi radians into degrees, we're now going to flip it to be pi times 180 degrees over pi radians. And that's, again, still 180 degrees equals pi radians. So it's really like I'm multiplying by 1, but my units cancel out, radians and radians cancel out, and leave me with just the 180 degrees. And then pi over pi cancels out, because pi divided by pi is 1, just like anything divided by itself is 1, and I'm left with just 180 degrees, which we know is correct. We already knew that pi radians is equal to 180 degrees. So let's do a slightly trickier one. If we had pi over 6 radians times 180 over pi, again, my pi's cancel, and I'm left with 180 divided by 6, and 180 divided by 6 is going to be 30 degrees. And then we answered this already, how many radians are in a circle, but if we wanted to do it mathematically, we could say there are 360 degrees in a circle. We're going to multiply that by 180 over pi. Nope, sorry, I did it backwards. We're going to multiply it by pi over 180. Because we are going from degrees to radians. So we're going to multiply by pi over 180, and 360 over 180 pi, but 360 divided by 180 is 2, so we get 2 pi. All right. So we're going to add a little bit of vocabulary to start talking about angles at an Algebra 2 level. And the way that we're going to really do this differently than I think you saw in geometry is we're going to think about angles as being on axes, on a graph. So an angle is in standard form. Pardon my handwriting. I have a touch screen here and I am not good at it. Standard form. Maybe I'm better off just typing these notes for you guys. I need to be able to actually read them. That would be helpful, right? Standard form. In standard form, if its vertex is located at the origin, which is that 0, 0 where the x and y axes cross, right? And one ray is on the positive x-axis. So remember, a ray is a line that goes on forever in one direction. So we've got, whoops, not the band one direction and not changing the slides yet. So we've got one ray here that is located from the origin on the positive x-axis, and that ray that is on the x-axis is called the initial ray. And the other ray, so this one that is going off and forming the other side of the other side of the angle here, this ray is called the terminal ray. Terminal means ending, so like a train terminal is where the train's route ends. The terminal ray is where your angle ends. So if the angle is measured in a counterclockwise direction, so that's starting at the initial ray and going this way, that is positive. So this is an angle of 120 degrees, and that's positive 120. But if we measured the other way around, if we started at this angle and drew a line that went around this way, clockwise, that measurement is negative. And we can find what this negative angle is because going all the way around like this whole way, would be a circle, and a circle is 360 degrees. So the whole circle would be 360, and just this portion of it is 120. So if I subtract that, I've got 240. So I know that this portion here is 240, but because I'm going clockwise instead of counterclockwise, it's negative 240. So we can find that negative angle, and those two angles are both in standard position because the vertex is located at the origin. They both have that initial ray on the x-axis, and they have the same terminal ray. In fact, I'm mad that our notes say terminal side. They should say terminal ray. Those are called coterminal angles because they're sharing that terminal ray. They're sharing both of those rays, but because they're going in opposite directions, they have different values. Okay, so quick check-in. What is the coterminal angle to negative 111 degrees? Okay, so once again, we have an angle that is in standard position on the x-axis, and if we go in the clockwise direction, we've got this 111 degrees, and that negative is really indicating direction here. If we go the other direction, if we go counterclockwise to get a positive angle here, that full thing is a circle that is 360 degrees. And the negative direction of it is 111 degrees. So if I subtract that, I get 249. So my positive angle must be 249 degrees. So 249 degrees and negative 111 degrees are coterminal angles. Oh, you know what? We're going to skip that for now. We'll come back to it. What you're really doing, yeah, sorry, I think I didn't save all my changes to these slides. Yeah, that's it for this beginning lesson. You've got radians, you've got angles in standard form, and you've got coterminal angles, and that's your three big takeaways from the day. You have a delta math to practice this. I hope you've enjoyed this introduction to trig. Hope you guys are staying safe and staying healthy and not going too stir crazy in your homes. Please email with any questions and try the delta math. Bye.